All right, guys, welcome back. We are doing lesson 7.2. No, there is not a 7.1, so you did not miss anything. Before you mute me and try to do this, there are some places where I really need you listening, so please don't mute me. All right, so today we're going to talk about rational functions. So what is a rational function? It's basically any number, a rational number is any number that can put into fraction form. So that includes whole numbers, negative numbers, and they give us some examples right here. So let's just dive into it. Now I am trying to make these videos a little quicker, so instead of going through the long way of graphing, I went ahead and put the graphs here so we can just get to the important stuff and talk about it. All right, so we have another key idea. All right, what is a simple rational function? So here's our graph. This is called a hyperbola. All right, hyperbola. So that is which consists of two symmetrical parts called branches. So these two parts are branches of the graph. So any function in this form has the same asymptotes, domain, and range as this function. All right, so anything, so like say if it was 2 over x, 3 over x, as long as that a value is not 0. I added this to the notes because I thought it was kind of important because we sometimes struggle with end behavior. It says, notice that 1 over x approaches 0 as x approaches infinity. So it's talking about right here. It's getting closer and closer to 0, and it's going towards positive infinity. All right, and then it says that explains why y equals 0. And that is our horizontal asymptote. So the asymptote is right here, the y-axis. That is your asymptote. All right, they have it written right there. I guess I could have just used that. But anyways, and then we have a vertical one of 0. So your vertical, I apologize if that's been moving. Your vertical one is not that far. It was supposed to stop right here at the y-axis. So your vertical asymptote is the y-axis. Your horizontal asymptote is the x-axis. So just some information that I thought would be helpful. So these can be very confusing. But I don't want you to be scared of them. If you notice throughout the lesson, I put use Desmos. All right, so they already graphed g of x for us. All right, they wanted us to do it, but instead of doing the long way, like I said, I went ahead and graphed it there. So the blue line on my paper is f, the red line is g. So we're going to pretend like we just worked out some x values and we got those. All right, so really the important part is comparing the graph to the graph of f of x, which was 1 over x. So what could we say about it? We could say that g is a little bit further away. So it's a little further away from the x and the y-axis. So the graph of g lies farther from the axis than the graph of f. So just saying g is a little further away. All right, both graphs lie in the first and third quadrants. So they didn't change quadrants. Remember, this is your first, second, and third and fourth quadrants. So they both lie in the first and third quadrants. And they have the same, so they're going to have the same asymptotes because, remember, this is the A is 4. So because it's in this same format, the asymptotes are the same, the domain is the same, and the range. So they have the same asymptotes, domain, and range. So the only way your range would change is based on maybe a translation, maybe a reflection, those kinds of things. All right, so I do have an extra credit opportunity with this one. And that is to compare, hold on. If you would like to start off this quarter with some extra credit, you can graph this on Desmos or in the graphing calculator, whichever, and then write a comparison of 1, 2, and 3. If you only feel like doing 1, I'll give you some. The more you do, the more extra credit points I will give you. So extra credit opportunity right there, starting off the quarter. Again, that goes on your practice, so you should see it on your practice grade. All right, moving along. So now we're going to talk about translations. And so right here, to graph a rational function in this form, follow these steps. So they tell us to draw the asymptote. Your x is equal to h. So your vertical asymptote is h, okay? And then your horizontal asymptote is k. If you remember before, we did talk about left and right changes your asymptote this way, up and down changes your asymptote that way. So the way that you could think about it is your h value gives you your vertical asymptote. And then your k value gives you your horizontal asymptote. All right, and so let's see. So right here, they don't give us, do they give us? No, they don't give us the numbers. But as you can see, they're saying this value here is your horizontal asymptote. This value where h is your vertical one. So again, I told you guys I'm not going to torture you with graphing these from scratch because you get to use Desmos. So why torture you? I know y'all are so happy. Finally, Miss Gill isn't torturing. Hopefully it'll make the video a little quicker too. All right, so we're going to pretend like we're using Desmos. I'm just going to go ahead and graph it for you. So I'm going to pause my end, and then it will be graphed when I come back. So in a moment, it will magically be graphed. Okay, so here's your hyperbolas graphed. And so if there's a little glare, because sometimes it goes with pencils, this is the point -6, 0, -4, 1, -3, 3. And then we have -1, -5, 0, -3, and 2, -2. I do, however, want to discuss how to determine your asymptotes based off of this equation so that you could know just by looking at the equation. All right, so remember this is our h value, but remember it's the opposite. So we would say when this one is -2. So at -2 would be our vertical asymptote. And then remember this one tells us our horizontal, and it's that number. All right, so what does that mean? That means that I have a vertical asymptote at -2. Oh, I didn't, I gotta fix my point, sorry, hold on. All right, maybe some of y'all caught that I didn't put -3, 2. Oh my good, yes, -3, 3. Did I? 1, 2, 3. Okay, I put it at the -2 spot. Okay, so now that we got that fixed, you know, I'm a little rusty on these videos. All right, so this is our vertical asymptote where x is -1. So this is where x equals not -1, -2, lady, where x is equal to -2. So that is, we get this based on that number in our denominator, okay? And then our horizontal asymptote is this -1, so it is right here. And the asymptote is the same for both of your branches of your graph. All right, so those are the same. All right, but they want us to answer these key features, and by now we should be able to start answering some of this. All right. Let's start with positive and negative. So again, your positive and negative is determined by the x-intercepts. So we have one x-intercept right here at -6. And the vertical asymptote is -2. The horizontal asymptote, remember, is -1. So our function is positive when x is between -6 and -2. So right here, it's above the x-axis. So we would say when x is between 6 and -2. So it's between this part. Remember, we're looking at what is just above the x-axis. So if we look at it, our -6 to our -2. All right, and then negative is what's below, but because of we have our asymptote here, we would say when x is less than -6 or greater than -2. So because we have this, it's below. And then our asymptote, we count, and that is to the right of it. So when it is greater than that. All right, so increasing and decreasing. So both branches show the function increasing. Remember, we read left to right, left to right. So both of them show increasing, so the function is increasing. But remember, because we have them asymptotes, that kind of like breaks up our function. So it's increasing when x is less than -2 and when x is greater than -2. You can also write those in interval notation. So when does it decrease? It doesn't. And remember, in big ideas, you would put no real numbers. All right, then describe the end behavior. So we have this end going this way. The graph has a horizontal asymptote of -1. So this end is going as y approaches -1, x is going to -infinity. So as y approaches -1, x approaches -infinity. All right, and then we're looking at this part. So we're not looking at 4. We just have two end behaviors still. So this one, as y is approaching -1, x is going to positive infinity. So as y approaches -1, x approaches positive infinity. So you're using your leftmost end and your rightmost end. All right. So just so you can practice this, we'll just do it with one. Let's just do, actually, so that way we can have one that is similar. Let's do number 6. So if you will graph that on Desmos, and then you are answering when is it positive, negative, increasing, or decreasing, and then the end behavior. So the same questions we just answered. Just give it a try, see where you think you may be. All right, so hopefully you gave it a try. Because I am on camera mode, not screen mode, I can't pull it up on Desmos. So hopefully you graphed it. And then remember, so this would be one of your asymptotes, and this is your other asymptote. All right, so this would actually be +1. So that would be your vertical asymptote. I'm just going to put VA for +1. And then this would be your horizontal asymptote. All right, so that way you get used to looking at this. And this does affect your domain and range too, so it's kind of helpful for that as well. But we're going to get into that in a minute. All right, let's move on to example 3. All right, so example 3, we have a table. All right, we looked at a graph, now we're looking at a table. So as always, you are looking at how does your function change from f of x to g of x. Notice the x hasn't changed, so there should be no horizontal movement. It should just be a vertical movement. If your x values aren't changing, it's only vertical. It's changing your y placement. All right, so you're looking at how do you go from this to this, this to this. So what could you do to this to get this? So I see these are easier to work with than the fractions, so I could look at how could I go from -2 to -6? Oh, I can multiply by 3, right? Can I do the same here? If -1 times 3 does that? Yes. So you could keep checking them. If I multiply -2/3 times 3, that would give me that. And if I multiplied 3 times -1/2, that would give me that. So basically we're multiplying by 3. So f of x times 3 equals our g of x. So what type of transformation uses multiplication? If you said stretching or shrinking, you are correct. And our 3 is greater than 1, so we would say it is a stretch. So the graph of g is a vertical stretch. Don't forget your factors by a factor of 3 of the graph of f. All right, that one wasn't too bad. I don't think I have. Yeah, I do. All right, so I have 2 graphs that you can pause and try for your, let me zoom out, for your self-assessment. So just this one, use the graph to describe the transformation. So just number 7, how does this graph transform? So if you will, just take a moment to think about that. Okay, so hopefully you paused. So if we look at this, notice how these two are on top of each other. That tells me that it didn't stretch or shrink, and it didn't go up or down. So if I look in comparison, I can look at this one and compare those, and then I could compare these 2 points. It appears to have moved to the right one time. So what type of transformation would that be? It would be a translation 1 unit to the right. All right, and so this one, they were just like, how would it change if you translated 1 unit up instead of 1 unit down? So if we were here, we would go up here, right? And then this would kind of move to here, this would kind of move to here. So these actually would cross. This would be about here, but these wouldn't. So this would actually end up crossing to show like a vertical movement, because this would go like up that way. So that would make your graph kind of go like that. All right, and then the same down here. So if it moved up 1, if we move this one up 1, that one up 1, eventually they would, let's see, if we go this way, then boom, 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 go that way, something like that. All right, that was fun. All right, so we do have example 4 left, and I do want to graph it, use Desmos, graph it, determine the domain and range. If you want to go ahead and do that, you can, and then I'm going to start a new video. It'll be a short video. Part 2 will be very short, but I have to end this video.